Planet Earth, our home among the stars. With the moon at our side, we orbit the sun. Through telescopes, we observe the starry sky, looking into the seemingly limitless universe, hoping to find answers to its mysteries. A 1,000 years ago, sky watchers recorded the explosion of a star. It was so bright, it could be seen in daylight. During the last few decades, strange rhythmic radio signals have been received from the still visible cloud. Astronomers also theorize about black holes among the stars. They search for what they believe to be stars so dense that nothing near them can escape from their gravity, not even light. Such is the nature of the universe we will see as we journey into outer space. We begin our exploration close to home with the sun, an average star like millions of others we see in the night sky. Orbiting the sun are the planets. Mercury, closest to the sun, scorched by its heat. Venus, hidden under a veil of ammonia clouds. Earth, so far the only planet we know that nurtures life. Mars. The patches of color led us to seek, but not find, life here. The asteroids, orbiting the sun, at times entering the Earth's atmosphere as meteors. Jupiter. Galileo saw this planet through his primitive telescope and discovered its 4 brightest moons. Saturn. Perhaps the loveliest object in the solar system, with thin rings and companion moons. Uranus. Rotating vertically, its elegant rings just recently discovered. Neptune, so far from Earth that little is known about it. Pluto, on the outermost rim of our solar system. Sharing the solar system with us are the comets, huge spheres of gas and ice orbiting the sun, buffeted by solar winds. Halley's Comet is the best known. It swings in a 76-year orbit. The gaseous tail, millions of miles long, crosses the orbits of several planets. Moving out of our solar system, on into space. At this very moment, somewhere out here, stars are being born. Others exploding, some dying, or shining down gently on planets like our own, perhaps warming the bodies of living beings. Stars, we now believe, have life cycles of their own. Their formation begins when immense clouds of hydrogen and helium gas are drawn together by gravitational forces. When the temperature reaches about 1,000,000 degrees, nuclear fusion is ignited, and a new star shines in the galaxy. Our star, the sun, was born billions of years ago. It now appears to be constant and unchanging. Yet, every second, 4 million tons of the sun's matter is converted into energy, which radiates into space. Someday, the sun will begin to run out of matter and energy. About 6 billion years from now, it will expand to about 50 times its present size. The red giant will scorch the earth. All life will die, and the oceans will dry up. Then, in only a few 100 million years, it will collapse. The scorched earth will begin to cool. Now, the sun will swell again. It will grow and grow, swallowing the planets, Mercury, Venus, and Earth. Then it will shrink to its final fate. Becoming a white dwarf, a small hot star. Finally, it will cool and fade, becoming a dark, dead star. No more will our sun shine in the galaxy. It will have lived for about 100 billion years. The period that promoted life on the Earth will be no more than a minor event. Our galaxy, the Milky Way, contains about 100 billion stars. Some are millions of times brighter than the sun, others smaller than our moon. Tipped on its edge, the Milky Way galaxy looks much like this. Not all the galaxy is stars and planets. Part is made of great clouds of gas and dust. These majestic galactic clouds are called nebulae. Nebulae are the birthplace of the stars. Perhaps it was in a nebula such as this that our sun and planets were created, and the chemical elements that make up our bodies were formed. Nebulae have long been a problem to astronomers because they often obscure the regions behind them. To observe conditions within the nebulae and beyond required another kind of telescope. In 1932, a young scientist, Karl Jansky, standing here by the framework of his radio telescope, discovered radio signals coming from the center of our galaxy. This discovery laid the foundation for radio astronomy. Now, radio observatories have been built around the world. In the Owens Valley, the California Institute of Technology operates a radio observatory. Here, faint radio signals from across the galaxy can be received, providing data impossible to get with optical telescopes. The antenna can track a point in the sky as the Earth rotates. At this moment, the antenna is aimed at a spot just above the horizon where a radio source has been discovered. An oscilloscope displays the signal as we home in on the distant radio source. This is it. The signal pulsates regularly 11 times per second. Regular as clockwork, like a coded message from outer space. At first, these signals puzzled astronomers. Now, they think they've solved the mystery. They believe the signals come from spinning neutron stars. As they spin, they send out a beam of radio waves much like a beam of light from a lighthouse. We call these spinning stars pulsars, because from Earth they appear to be pulsating. More than 300 pulsars have been identified. The rhythm of each is unique. Some pulse once every 3.5 seconds, others 30 times per second. Imagine the incredible spinning rate of these stars, 30 times per second, nearly 3 million times faster than the Earth's rotation. Also in our galaxy, we believe there are objects called black holes, stars so massive that even nearby light cannot escape their gravity. This is the current theory. When a giant star collapses, an astounding thing happens. The star becomes extremely small and incredibly dense. Nearby energy and matter cannot escape the pull of its gravity. Because of this, we cannot see the star or receive its radio energy. We call these invisible stars black holes. Stars that shrink and cool, stars that explode, spinning stars, and stars that suck in light and matter. All are found in our galaxy. Beyond it lie unbelievably remote realms which, until this century, were almost totally unknown. In the 1920s, a great observatory was being built in Southern California on Mount Wilson. Its telescope was equipped with the largest reflector ever made, a mirrored round glass slab 100 inches in diameter. At that time, many astronomers believed the Milky Way was the only galaxy. Others, such as Edwin Hubble, argued there must be more. Pointing the telescope at what was believed to be nearby star clouds, he calculated their distances and proved that they were millions of light years away, far beyond the bounds of our galaxy. He discovered here, visible between the stars, countless distant galaxies, revealing a universe billions of times larger than we had suspected. This is the nearby galaxy in Andromeda. Its light travels for 2.5 million years to reach us. For the first time, we realized that light from some distant galaxies reaching us now left its source even before the Earth was formed. We discovered that there are hundreds of billions of galaxies in the universe, more than there are stars in our own galaxy. Radio signals and light from distant galaxies suggest a universe even more extraordinary than anyone in 1920 imagined. For one thing, objects called quasars have been discovered. They appear quite bright and look like nearby stars, but they are far beyond our galactic neighbors and emit fantastic amounts of energy which defy explanation. And there's the question of the origin of the universe itself. The data, when analyzed, indicate that the galaxies are spreading apart, that the universe is, in fact, expanding. The reason for this takes us back to the very birth of the universe. Many astronomers now believe the universe was born when an immense fireball exploded, casting into space radiation which later formed into the matter which makes up the universe. Some astronomers believe the expanding universe will eventually fall back, pulled by its own gravity into an enormous fireball. Will it, in time, explode again, creating a fresh, new, expanding and contracting universe? The search continues for answers to these mysteries beyond our solar system.